Right, so what we've been working on, actually, the exponent stuff is just simplified, being able to write them in different forms. But what we're actually going to look at now is slightly different, which is rather than the answer, the value of it being put in a different form, what if I asked you, instead to evaluate, if I asked you to solve 2 to the power of x, so I want to know what the exponent is. So if I gave you an easy one, like 2 to the power of x equals 64, okay, how would you go about telling me what x was?
I would isolate the variable. Could it be
Six.
Okay, you would isolate, but you would say just 6 because?
Just 2 times to the exponent 5 equals 32 and 32 times 6.
Yeah, so we already know that one, so actually we know that x is 6, but that's kind of a memorising it.
Yeah,
it's obvious.
It's obvious, but if you
Yeah.
have to trade work.
Exactly. So, but that's the kind of one that I can ask you. So this is the problem. When you are asked to solve equations with x, you, like you said, you try and isolate the variable. Right? You use inverse operations to do that. So for instance, this you can do without having to do that process. But what if I said to you 2 to the power of x equals 120? What do we know about x?
Well, that's not actually a
It's
power.
to the square root of 2.
Well, no, we can't. We don't want to do the square root of 2 because the square root is only the opposite of
X root.
squaring. So we've got to, yeah, potentially we could do that. Yeah?
Yeah,
Because that's the opposite of power.
yeah.
Doesn't help me though, does it?
No.
I'm still guessing. And what do we know? Well, we know that 2 to the power of 7 is going to be 128.
Oh, it's to the
And
power,
I know that 2 to the power of 6 is 64.
2 to the power of 6.
So it's going to be 2 to the power of 6 points. But who knows? How do we? You can try and guess with your calculator, but you have, like, at what point do you get the answer exact? Because what if it's a decimal that goes on forever? You will never be able to write. You'll never be able to prove it. So we actually need a different method. All right. Having the unknown as the power. So Kieran was working on having equations as the power. This is where we're moving on to. All right. What if I wanted to know what the power was that gave me a particular value? And that's where logarithms come in. Okay. So I would not do this root here. That's something that it doesn't make it any easier for me. What I'm actually going to do is this. I'm going to take, and I want you to pay attention to the language that I use here because I want you to get to the habit of saying it correctly. So, and it will help you. So I'm going to say it's log, meaning logarithm. It's going to be log to the base 2 of 120 equals x. Yes, sir.
Another way you could do it, I think, I don't know, you could basically get 120 divided by the base before it, so 64, and then do a whole bunch of voodoo, and I got, it would be 2 to the power of 6.9375. I just want to see if that's the answer. I'm
Well,
just
let's
calling
have a
it
look.
out if it is the answer.
But I've got log to the base 2 of 120. Now I can do it on this calculator. The manual calculators, we'll have to have a look. Right, log to the base 2 of 120. So that gives me x, that isolates the x. Now you'll notice that I said very clearly it's log to the base 2. That's because this number here, 2 to the power of x, I think we've already said the x is the exponent, okay? But the 2 is the base. That's why I said log to the base 2 of this answer will isolate the x, give me the x value. It's doing the inverse of, okay? So that's because what I'm going to ask you to do in a bit is rewrite the exponential equation as a logarithmic equation. Alright? So a logarithmic equation is the inverse of an exponential equation. Now I can find that value because I've got it on my calculator. Alright? So I don't, you on your calculators. So I've got, I think, I might have an old setup.
Oh, sorry.
So, when we need log to the base 2, so your calculators, these things, only work in log to the base 10. If you've got one of these, right, which is why we want them, the log, you can choose the base. But this one needs updating, which means you can't, okay, which is a shame.
So which specific model do you use?
TI-84, but I'll confirm that when we've got one of these, yeah, one of those lovely ones. Okay? But what we can do, this is what we had to do before we had a calculator that would allow us to do it. We had to do what's called a change of base. Alright? So for instance, this change of base formula says if you've got log to the base something of something, okay? So log to the base 2 of 120.
Yeah.
If I want to know what that equals, now my calculator won't tell me at the moment because I've not got a fancy enough one. I can rewrite it as log to the base anything, okay? So log to the base 10, which we just write as log on our calculator, that's what you'll see, all right? Of x, which is the 120, divided by log to the base 10 of b the base, so 2. Okay? Got that?
Yeah.
So that's called a change of base formula. And we need that if we don't have a calculator that can put log to the base anything in. And our calculators only have log to the base 10. So what we can do on these calculators now, log to the base 10 is just log. Right? Log. So you can put it in as log 120, okay, divided by log 2. Press equals, and you get the answer
6.9068.
6.9089059. Okay. So what does that mean? That means that 2 to the power of that equals 120. Okay? That's what we've got.
Log 120 divided by log 2.
Okay. So I tell you what, let's have a bit of a practice. Okay? Using that formula, I would like you to evaluate for me log to the base 3 of 45, log to the base 7 of 216, log to the base 1.5 of 0.05. Okay? So I'd like you to try and evaluate those for me.
You can solve.
Well, what do they equal?
Oh, okay.
Wait, how many decimal points again?
Should we give it to 2 decimal places? The only logarithm I can do on my calculator is log to the base 10. So here, look, my a, because of the situation I'm in, I'm going to forget about that. It's going to be a log to the base 10. Now log to the base 10, because we use it a lot, just is written as log. Any other base, we would put in a number. Okay.
I'm done.
4, 6, 4, 9.
So for instance, this first one we would write as log to the base 10 of 45 divided by log to the base 10 of 3. And what do I get as my answer? What is that there?
You go log.
I'm just going to do it again. I'm pretty sure.
I've done D too. I've done all of them.
Okay.
I think so. I think I took the last one wrong.
Correct. Zoe?
Log.
Log
And then
5,
500
500.
equals 3.86.
Yeah,
How did you do that?
Oh, log 500 open bracket divided by log open bracket 5.
Okay. So that equaled what you say again?
3.86.
3.8. Okay. Cool. Now, if you have the more advanced calculator, this step's not necessary. So I think you don't need it, right? This stop is out. This is the change of base formula. It's not necessary if your calculator will do it for you. All right. Ashley, do you want to tell me work us through this one?
So log to the base 2.3.
Yeah.
And then 4.2. Number 2 equals 1.89.
1.89. Because yours does it without needing the change of base. Okay, so the next phase just adds one little extra step. Nick?
So what you do is you just do the same thing, just forget that the 2 is there, and then right at the end you just divide by 2.
So I'm just going to rewrite this then. Log to the base 7 of 50 equals 2x is what I'm going to say now. Equals the entire power, right? Not part of it, it's the entire power. So then I say log to the base 7 of 50 is
2.02.
2.02, and 2.02 equals 2x,
So then you just get 1.0.
so x is
Oh, I got it.
1.01. Okay?
That's fine, when you do the same thing. So,
Same thing. So we've got log to the base
11.
11 of
326.
326 equals
Yeah,
2x.
1.42.
1.42 is 2x plus 1.
Subtract 1 from both sides, and then divide by 2. You get 0.2.
0.21 is x. Okay? So again, just to reaffirm in your knowledge, alright? Yeah, go on.
When I put log to the base 11 and then divide to 326, it's 2.41.
Is it?
Yes.
So this is not correct.
Oh,
So that is 2.41, which makes one. I'm going by your trust in you.
No, I think.
1.41, and then the answer would be
0.71.
again rounded to.
Plus,
I guess we rounded this too early. If I want to round the final answer, I shouldn't round earlier. Yeah.
why would you divide? Oh, never mind.
2x. Yeah, is that what?
2x, 1. So that plus 1.
So minus 1 on both sides to get rid of the plus 1.
What's this? So plus 1 is up on the exponent. Doesn't that mean like?
No, so
Plus
remember
1.
when I do the logarithm, I get the whole exponent.
Yeah.
So 2x plus 1 equals, yeah?
But since plus 1 is like is different from the 2 because 2x is 2 times x,
Yeah,
but x plus 1 say, like, x was 7 in this case,
Yeah.
X plus 1 would be 8, so the power 8, right?
No, but I've got 2x plus 1. So if x was 7, the power would be 2 times 7, 14, plus 1 would be 15. The power would be 15. Now in this case, the power is 2.41. So I've got 11 to the power of 2.41
Yeah.
equals 326.
Yeah.
Now, that's what I was just about to say. Now, I then know that that is equal to 2x plus 1 from over here. Now, I've asked you to solve for x, not the power.
Yeah.
Yeah? Okay. Still lost
I
what
don't
way?
think that works. 11 to the power.
Just,
Well, remember we've rounded. So does it work roughly?
Oh.
300.
like,
never
but can you just
23.
take away power by subtracting it?
I haven't.
But I
So let's. Okay, well.
yeah, I know, you just break.
Right, let me redo this one with you, for you. Did you get the other one, the 2x one?
Yeah.
Okay. So, the statement that I'm making is, alright, just in case anyone else. So I know to work out a power, alright, I have to do the logarithm of that base of the answer, the value, 326. If I do that, I get the power. What's the power? 2x plus 1 is the power.
Yeah.
Now what we've done is we've evaluated this and got an answer of 2.41.
Yeah.
That's that whole thing. So I know the power is 11 to the power of 2.41. So that must be the same as 2x plus 1. So I've got 2.41 must equal 2x plus 1.
Yes,
So now I've got a linear equation. Now how do you solve for x?
Minus 40.
You take away the 1 from both sides. Get 1.41 equals 2x. Divided by 2 gives me the x, which is not the power on its own, it's just the x, is 0.7.
Yeah.
Alright? Sort of, taste. Okay. So that's kind of an introduction to just logarithms as the inverse of the exponents. What we still need to be able to do, and we'll do this on Monday, is if I ask you, because we've done it with exponents, simply simplify, we want to be able to put things in different forms to be able to work on it. What if I said to you, evaluate, or even simplify, 2 log to the base 2 of 3 plus 4 log to the base 2 of 8 minus 3 log to the base 2 of 16. What we want to be able to do, and we're going to do this on Monday, is use the laws of logarithms in the same way that we did laws of exponents to simplify that so it becomes a lot easier to work with. Alright, because you'll understand that a lot of these will now be decimals, and we don't want to turn them into decimals and round. Okay?
Lunch.
Lunch as well.
Lunch, yeah.
Yeah. It's 41%.
Don't forget, if Nick's channel is rubbish, it's this spot.
Oh.